this lesson we'll illustrate another method to solve a quadratic equation, and that is the square root property. Before I tell you the square root property, let me show you some examples that illustrate this whole concept. Let's suppose I wanted to solve the equation x squared equals 36. Using the zero product property, we can set one side equal to 0 and factor that quadratic expression and then set each factor to 0. That would give us x squared minus 36 equals 0. X squared minus 36 is the difference of two squares, and that factors as the product of conjugates, x minus 6 times x plus 6. The equation is now x minus 6 times x plus 6 equals 0, which is in the form that we can apply the zero product property. Setting each factor equal to 0, we get x minus 6 equals 0, or x plus 6 equals 0. Solving these two linear equations gives us x equals 6, or x equals negative 6. First seeing this equation, you may have thought, oh, I know the solution. If x squared is 36, x is the square root of 36, or 6. That only gives us one solution. Remember that the degree tells us the number of solutions. We should have two solutions. So another way to think about this is, what are all of the numbers that we can square to get 36? Well, we can square 6 to get 36, but we can also square negative 6. 6 and negative 6 are said to be the square roots of 36. In other words, if x squared equals 36, x is plus or minus the square root of 36, or plus or minus 6. This is an illustration of the square root property. The square root property states that if x squared equals some number k, then x is equal to plus or minus the square root of k. The most common mistake I see students doing here is forgetting about the negative value. So this process is a little bit different, a lot different than the zero product property. This time we have to have x squared equals some number, and the x doesn't just have to be a single variable, it can be some quantity squared equals a number. Let's look at an example. Solve 3x squared equals 12. Before we can apply the square root property, we need the quantity x squared on a side by itself, and that means that that x squared term has to have a coefficient of 1. So we first divide each side by 3 to get x squared equals 4. Now the equation is in the form that the square root property can be applied. If x squared equals 4, then x equals plus or minus the square root of 4. Simplifying that gives us plus or minus 2 for the solutions. Now plus or minus 2 is also written as negative 2 comma 2. Understand it as two distinct solutions. Example 2, x squared plus 25 equals 0. We can apply the square root property because we don't have an x term. We can isolate the x squared term by subtracting 25 from each side. That gives us x squared equals negative 25. To solve for x, we apply the square root property to get x equals plus or minus the square root of negative 25. You might recall that the square root of negative 25 is not a real number. That is an imaginary number. Recall that the square root of negative 1 is the imaginary unit I. Therefore, the square root of negative 25 is 5i. This equation then has two imaginary solutions, specifically negative 5i and 5i. Example 3, to solve x plus 7 quantities squared equals 8. We can apply the square root property because we have some quantity squared equals 8. So to get the x outside of the square, I have to apply the square root property, which tells us that x plus 7 has to be plus or minus the square root of 8. The square root of 8 simplifies by finding a perfect square of 4 times 2. Therefore, x plus 7 equals plus or minus 2 on the square root of 2. Subtracting 7 from each side to solve for x gives us x equals negative 7 plus or minus 2 on the square root of 2. This is equivalent to negative 7 plus 2 on the square root of 2, and negative 7 minus 2 on the square root of 2. Those expressions cannot be simplified any further because 7 and 2 radical 2 are not like radicals, so we cannot add them. Just need to keep that in that particular form. So in summary, to solve the square root property, x squared equals a number k, x equals plus or minus the square root of k.